Good evening, my dear students. Good evening once again. Myself is Dr. B.N. Rao, having my dear students 17 years of teaching experience. Out of that, from the last 10 years, I was supposed to be teaching the various subjects, my dear students, in the Department of Electronics and Communications and Instrumentation for GATE and Engineering Services, competitive level examinations, my dear students. Okay, the subjects like communications, core instrumentation, electronic device and VLSI design, my dear students. Okay, nearly I dealt 200 plus batches across all the locations of the country, okay, covering the northern and southern parts of the India for these particular subjects, my dear students. Okay, similarly, when considered subscriptions, the Unacademy is having the two important subscriptions, my dear students. The very important subscriptions. Just I would like to bring it to your notice. Okay, so and these particular subscriptions are very important when comes over here, my dear students. Okay, and these particular subscriptions that plays a vital role over here, my dear students. So when going for these particular subscriptions, my dear students, as I told you, okay, it is of okay, the two subscriptions, one is called okay, the iconic subscription, and second one is the what, my dear students, the very important subscription is plus subscription. Okay, if you are going for the iconic subscription, my dear students, a personal coach is dedicated for each and every student. He will explain the subject in a detailed manner, my dear students. Okay, over here, okay, with respect to the structured timetable. And also, you are going to receive the expert guidelines from the topmost educators of the Unacademy, and the mains level guidance also you are going to get, my dear students, over here. When comes to the plus subscription, my dear students, when you are going to take this particular subscription, you are not only accessing the live classes from the topmost educators of the Academy, but also, my dear students, you can practice the unlimited test series with respect to the structured timetable, my dear students. Okay, this is about the next subscription, my dear students. Okay, similarly, these are all the subscriptions that plays a vital role as far as the Unacademy is concerned, my dear students. Okay, similarly, when I am going for the fee structures, my dear students, the fee structures when comes into the very important, okay, for plus subscription and okay, the iconic subscription. For the plus subscription, my dear students, if you are going for this one, okay, the plus subscription for 12 months, the fee structure itself is 27,235, and you can use my code and get the discount. Okay, similarly, for the same plus subscription for 18 months, the fee structure is 34,650, and you can use my code and get the discount. Okay, similarly, for the same plus subscription for 24 months, the fee structure is 39,600, and you can use my code and get the discount. Okay, these are the subscriptions that are concerned with respect to the Unacademy plus subscription. Now when comes into the Unacademy, that is iconic subscription, my dear students, the fee structure for 12 months itself is okay, 45,225, and you can use my code and get the discount. Okay, similarly, for 24 months, the fee structure is 66,600. You can use my code and get the discount, my dear students. Okay, similarly, my dear students, the plus batches taken by the top faculties inside the Unacademy itself is in the departments of electrical and ECE. Okay, these are the various faculties, my dear students, where they are going to take the subjects in a detailed manner. Okay, see here, target engineering services prelims 2021. Okay, 2021, my dear students, and the electrical batch, that is D, my dear students, already started, and it will be teaching in both English and Hindi, my dear students. Okay, similarly, the English and Hindi rank booster batch for GATE 2021, it is already started. It is also teaching in English and Hindi. Similarly, target engineering services prelims 2021 batch C, my dear students, this is also teaching in English and Hindi, my dear students. Okay, and one more batch, rank booster batch, my dear students, okay, for GATE 2021, this is also teaching in English and Hindi, my dear students, for the inside the students, my dear students. Okay, similarly, ascend. Okay, for gate 2023, my dear students, already the ECE batch A, that is starting from 21st of the December, my dear students, the top most faculties of the Unacademy. Okay, these faculties are going to teach you in detailed manner, my dear students. Okay, similarly, ascend for gate 2023, this is also teaching in English and Hindi, my dear students, and starts on 21st of the December, coming soon, my dear students. Okay, over these particular batches. Similarly, evolve for gate 2022, my dear students, this batch already English and Hindi, my dear students, already. Okay, this is also starting from 21st of the December. Similarly, evolve from the gate 2022 English and Hindi starts on 21st of the December, my dear students. These batches also going to teach you by the topmost faculties of the inside Unacademy platform, my dear students. Okay, similarly, for gate crash course for the Telugu people, my dear students, happening on Saturdays and Sundays. In weekdays, my dear students, okay, in weekdays only, okay, the classes that are going to be common, but crash course only on weekends, my dear students. Okay, these are all the faculties, those who are going to teach you the subject, my dear students, in a detailed manner. Okay, as far as Unacademy Telugu channel is concerned, my dear students. Okay, and the Beam Shankar sir is teaching digital electronics and networks, and here itself, okay, the mathematics professor Venkatekrishna sir is teaching the mathematics and that is foundation mathematics, and that is most reputed aptitude faculty Sharma sir is teaching, my dear students, that is aptitude, and myself in weekdays I am teaching communications, weekends EDC, and the electrical core faculties like Bonshekar and Surendra sir is teaching, my dear students, the subjects like machines, power electronics and power systems, my dear students. Okay, don't miss this opportunity and attend all these particular classes, my dear students. Okay, similarly, that I told you that the gate December month schedule for weekdays, communications, electrical machines, engineering, mathematics, power systems and aptitude, my dear students, that is from 4 p.m. to 9:30 p.m., my dear students, and weekends. Okay, the faculties, okay, they are going to teach you the subjects, my dear students. The very important is power electronics, EDC and aptitude, my dear students, that is on the, okay, weekends, my dear students. Okay, very important things that you need to remember over here when comes into these particular things, my dear students. Okay, these are all the important things as far as Unacademy Telugu channel is concerned. Similarly, crash course, my dear students, EDC, okay, already it is running successfully, okay, in weekends only, that is 4 p.m. to 6 p.m., my dear students. Okay, so these are the one more important thing that's I would like to, okay, bring it to your notice, my dear students. Okay, similarly, before entering into the subject, a legendary educator is coming to launch soon, my dear students. Okay, please wait and okay, watch this particular, okay, the legendary educator and his introduction, my dear students. Okay, these are all the general things, just I would like to bring it to your notice before entering into the subject, my dear students. Okay, Unacademy Telugu channel already have started, my dear students, probability, okay, probability, my dear students, and the random signal theory, okay, already have been started, and okay, and these class also going on and running successfully, my dear students. Okay, in today's class, okay, I am going to teach you the continuation of the previous class, my dear students, that there are some standard distribution functions. Okay, in the previous session I have finished about, okay, that is the two important that is distribution functions, my dear students. One is exponential distribution function and second one is a Laplacian distribution function, my dear students. Okay, in this particular session I am going for the other distribution functions and the previous year questions based upon the other distribution functions, my dear students. Okay, similarly, now I am going for the today's class is the next distribution function, my dear students, and that particular distribution is called Rayleigh distribution. Rayleigh distribution function. Another important distribution function, my dear students, Rayleigh distribution function. Okay, now here also, like in the previous class what we had seen, okay, we are also going to see over here, my dear students, in this particular session regarding the CDFs, cumulative distribution functions, and the probability density functions. Okay, I already told you that the cumulative distribution function is represented by capital F of x, and probability density function is indicated by small f of x, my dear students. Okay, now in the previous session what we had seen, like that we are going to see some more distribution functions over here, my dear students, in a detailed manner. Okay, so before entering into the topic, once again I have represented in the previous class. Please go for the those who has not watched the previous class recordings has to go for the previous recording, my dear students. Okay, similarly f of x itself is the very important thing, my dear friends. As I told you that there are two types of distributions. Okay, and these particular distributions plays a vital role over here. Okay, and those particular distributions under Rayleigh I am going to teach you, my dear students. Okay, and that one is f of x, and that one is f of x, my dear students. F of x equal to, okay, x by a square into exponential of minus x square by 2a square, my dear students. Okay, into u of x. Okay, this is the probability density function, my dear students, for the Rayleigh distribution. Okay, for the Rayleigh distribution, my dear students. Okay, similarly capital F of x, which is equal to, my dear students, 1 minus exponential of minus x square by 2a square, my dear students. Okay, 2a square. Okay, and this value is x is greater than 0, and this particular value equal to 0 when, my dear students, when x is less than 0. Okay, this is probability density function, and this is cumulative distribution function or probability distribution function, my dear students. Okay, and let us go for the graphs like the previous standard distribution functions, my dear students. Okay, here also my dear students, f of x with respect to the x, my dear students, this is the Rayleigh distribution function, my dear students. Up to here it is a. Similarly, we need to represent, my dear students, for the very important one, and this one is capital F of x. For what? CDF, cumulative distribution function, my dear students. Like that it is there, my dear students. Like that it is there, my dear students, and this particular value is 1. This particular value is 1, my dear students. Okay, this is what kind of distribution? Okay, cumulative distribution functions for Rayleigh. Okay, my dear students. Okay, very important over here, my dear students, before entering into the subject. Okay, so the continuation of the next one. Okay, this is about the Rayleigh distribution function, my dear students. Okay, their PDFs and CDFs. Okay, similarly we are going for the very important one, my dear students. Now we are entering into the topic, and that particular topic is Gaussian distribution and Gaussian density function, my dear students. Okay, very important, my dear students. Okay, so you need to concentrate over here. Okay, based upon this particular one, because continuously 3 times 3 questions has been asked, my dear students, based upon this particular distribution function, my dear students. Okay, and that particular one is very important over here. Based upon this particular function, we are not only going for the theory but also solving the various problems, my dear students. Okay, so here Gaussian density function, Gaussian, my dear students, Gaussian density function, my dear students. Generally here also two functions are there, Gaussian density and Gaussian distribution. First we will complete the Gaussian density function, my dear students. Okay, see here, Gaussian density function. If you are representing a random variable, okay, capital X is to be said to be a Gaussian, a random variable, capital X, my dear students, said to be Gaussian. Said to be Gaussian. My dear students, first density means small f of x. Later I am going for the Gaussian distribution. Okay, very important, my dear students. 1 by under square root of 2 pi into sigma square into e power minus x minus m whole square by 2 into sigma square. What is m, my dear students? M is nothing but, in this one, m is nothing but mean of the random variable. Mean. What is random variable? A variable which is independent of time is random variable. Random process. A variable which is dependent on time is a random process. Okay. Mean of what? Random variable. My dear students, very important. And sigma square itself is the variance. Here also, my dear students, we are going to study the various conditions over here. Please alert over here. Variance, my dear students. Okay. So, it is represented by, my dear students, the Gaussian. Okay. That is, the Gaussian density function is also represented by, my dear students, n of mean and sigma square, because it consists of the two parameters. One is the mean and this one. Okay, this is, my dear students. Okay, and this function, when I representing with the mean and variance with n, and this one is called normalized Gaussian density function. Normalized Gaussian density function. Normalized Gaussian density function, my dear students. Okay, in this particular function, my dear students, if we assume, if you are going to take it m equal to 0 and, my dear students, sigma square equal to 1, sigma square equal to 1, my dear students, if I am going to take it, then its function will be changed as n of 0 comma 1. Okay, and this function is called, this is normalized Gaussian density function. By keeping the m equal to 0 and the variance equal to 1, this function will become the standardized normal Gaussian density function, and this one is standardized, okay, normal Gaussian density function. Gaussian density function, GDF. Okay, my dear students. Okay, when I'm keeping the values in the normalized, in the standardized, my dear students, Gaussian density function, how we are representing? We are representing the values by keeping the m equal to 0 and sigma square equal to 1. Then how it will be? N of 0 comma 1 equal to, my dear students, okay, f of x, which is equal to 1 by 2 pi sigma square into exponential of m equal to 0. So when I am keeping the m equal to 0, then it is becoming minus x square by 2, because this is becoming 0 and this is becoming 1, my dear students. Okay, that's the reason you are getting this particular one over here, my dear students. Okay, very important. Okay, similarly, now here one more thing has been asked over here in this particular function, my dear students. Okay, let me explain. So this is about the two conditions. Okay, every condition has been asked in the previous paper. Similarly, my dear students, I am going for the next condition. Okay, what is the maximum value, my dear students, of the Gaussian density function? Maximum value of Gaussian density function, my dear students. Maximum value of the Gaussian density function, my dear students. Okay, very important. See here, generally the Gaussian density function n of m, my dear students, okay, which is equal to okay f of x, generalized function 1 by under square root of 2 pi into sigma square into e power minus, this is the generalized function. I am taking the first function, which is called a normalized Gaussian density function, not standardized, by 2 into sigma square. Now in this particular function I want to get the maximum value. To get the maximum value, always d by dx of f of x equal to 0, which is equal to 0, my dear students. Then what happens? D by dx, my dear students, write down this value, 1 by 2 pi into sigma square into e power minus x minus m whole square divided by 2 sigma square, okay, which is equal to 0. I am representing in this particular fashion, taking this particular function in this particular fashion, my dear students. Okay, similarly now what are the value you are getting is very important. So when I am doing like this, differentiate this one, bring back this outside, bring back this outside, e into minus x minus m whole square, my dear students, into 2 into x minus m divided by 2 sigma square, my dear students. Okay, which is equal to 0, which is equal to 0, my dear students. Okay, anyhow this is minus, here itself is minus, so whatever the term you are getting is the minus over here because of the minus x2 into here x minus 1 and minus here, but for minus x it is how much, my dear students? Minus 1. Then automatically what happens, my dear students? This is becoming plus, this is becoming plus, my dear students, which is equal to 0. So all these particular values are equating to 0, only the term is there, x minus 1. Okay, x minus 1 equal to 0, then x equal to m, my dear students, x equal to m, my dear students. Okay, the maximum value of f of x. Now substitute, my dear students, this particular one in this particular expression, then only you are getting the maximum value of the f of x, my dear students. Okay, now I am substituting this value, my dear students, in this particular expression. In this particular expression, my dear students. Okay, by substituting the value x equal to m, then what happens, my dear students? The very important is f of x. It will be changed, my dear students, at x equal to m, the maximum value This is the maximum value, my dear friends, which is equal to 1 by, this is the value, my dear friends, you are going to get over here. So because in the previous expression, see here, x equal to m means 0. Only the term that is left is this only. That is the term I have written over here, my dear friends. Okay, this is okay. Now we are going to study about here also the very important thing is that the probability density function we have seen. But what is this graph? Now what kind of things we are going to know from the graph? Those things also I am going to tell you. Case 1, my dear students. Okay, so here the mean means if the mean lies at a distance a on the right hand side of the curve, PDF curve. See here, if the mean, my dear friends, lies at a distance a at the right hand curve, my dear friends, of the PDF, my dear friends. Now see here, this is the PDF. This is the PDF. PDF, my dear friends. See, if you are going to take the PDF, probability density function, see, this is the curve. This is m1 equal to a. Mean lies at a distance. Okay, that is a wave over here, my dear friends. Okay, then at a distance a from the origin. Here, if the mean lies at a distance a from the right hand side curve of the PDF at a distance a. All these are the questions, my dear friends. Okay, then he is asking what is the mean square value and what is the variance. Okay, now it is at a, therefore m1 equal to a. Then what is the, my dear friends, see the mean square value and variance. What is variance? Variance equal to m2 minus m1 square. Okay, therefore m2 equal to what, my dear friends? Sigma square plus m1 square, which is equal to sigma square plus a square, my dear friends. Sigma square plus a square, my dear friends. Okay, if it is lying at a distance a, my dear students. Okay, these things you need to remember over here, my dear students. Okay, variance is always, what is variance? Substitute here, a square. Therefore sigma square equal to, okay, m2 minus a square. This is variance, this is mean square value, this is mean value. Now there is one more question asked. If the mean lies exactly at the origin, if it is exactly at the origin, then what happens, my dear students? This is becoming 0. The mean is becoming 0, my dear students. Okay, the mean is becoming the 0. And again here the formula, how the formula over here? Okay, here the formula itself is in this case when I am writing the formula. What is the general formula? F of x equal to 1 by under square root of into e power minus x minus m equal to mean equal to a square by 2a square, 2 into sigma square. This is when mean lies right side at a distance a. Now case 2. Case 2, my dear students. If I am going to take the case 2, my dear students, the very important case 2. If the mean is exactly at origin, mean is exactly at origin, my dear students. M1 equal to 0. Then this amplitude comes over here at the center. Okay, I am representing that only. Like this, if it is there, the mean is at origin. M1 means here 0, means the value of A equal to 0, my dear students. Substitute here. Then what is the formula of f of x? F of x equal to 1 by under square root of 2 pi into sigma square into minus e power, my dear students. Okay, very important. Put m equal to 0. Okay, minus x square by 2 into sigma square, my dear students. Okay, you are going to get this particular one. Here also we need to find out the mean square value and variance. Okay, mean equal to 0. Then mean square value variance equal to this is means when exactly as in variance is equal to mean square value. Variance is equal to mean square value, my dear students. Okay, all these things are very important, my dear students. Okay, if it lies at the two cases we have studied, my dear students. Okay, and different. Okay, when what kind of condition is there? If you are representing in normalized Gaussian density function, what kind of condition is there? If you are representing in standardized normal Gaussian density function, my dear students, and what kind of condition is there? We are representing when the mean is at a distance away from the right hand side, when it lies at the origin, my dear students. Okay, similarly all these are very important, my dear students. Okay, similarly we need to represent the Gaussian distribution function. Very important, my dear students. This is also based upon this, the previous problems has been asked based upon this particular concept, my dear students. Okay, then here, okay, here also capital F of x, always CDF, or it is also called PDF, probability distribution function, not density. Okay, then here capital F of x equal to 1 minus q, my dear friends, into x minus m by rho. Okay, what happens? This is the mean and this is the variance. This is mean, my dear students, and this is variance. Okay, how to represent these particular graphs? Just graphs are for your understanding. They won't be asked at the gate competitive level. X, my dear students, like this. The curve is there, my dear friends, at a distance away. This is a curve for CDF, my dear friends. Okay, the CDF of what? Gaussian, my dear friends. Okay, so all these things are very important over here, my dear friends. Okay, now we are going to solve the one problem based upon the these particular one, my dear friends. Okay, what kind of the questions will be asked based upon this particular one? Okay, now if x, capital X, My dear students, is a Gaussian random variable. Is a Gaussian random variable with m equal to 3 and sigma square equal to 4. My dear students, find the probability. My dear students, x is less than or equal 5.5. Okay, whenever the structure will be like this, immediately you have the idea. Previous recordings వెళ్ళాలి. Previous recording లో చెక్ చేసుకోండి. ఇలా ఉందంటే నథింగ్ బట్ అదేంది CDF అని అర్థం. This is nothing but a CDF, my dear students. Okay, probability distribution function, or it is also called CDF, my dear students. Okay, so here P of x is less than or equal to 5.5, which is equal to, my dear students, f. So nothing but this particular value. Okay, so f of x, capital X, I told you, x value can represent with small or capital. I am representing here because I already have taken a capital here. Capital X, write down the formula previous. This particular formula, 1 minus q. Okay, x minus m by rho. Okay, which is equal to 1 minus q into x minus m by rho. My dear students, okay, like that it is there. So it is 1 minus q into x. What is the value of x? X equal ga 5.5 minus mean value 3, my dear students, 3, and divided by sigma square. Sigma square equal to 4. Then what happens to sigma value? 2, my dear students. So the answer itself is, this is the answer, 1 minus q of, my dear students, 2.5 by 2. Okay, so this is the answer, my dear students. Okay, 2.5 by 2, which is equal to 1 minus q of 1.25. Like that the questions will be asked in the previous paper. Okay, now see here, next problem. Next problem, my dear students, very very important one. Listen carefully. Here one more important thing I would like to share with you, my dear students. If under brackets this is called x, my dear students, generally in q functions, this is one more thing, q of x plus q power minus x equal to 1, my dear students. Okay, so it is also equal to, because it is nothing but q of minus x equal to 1 minus q of x. 1 minus q of x, my dear students. Okay, which is equal to, same, my dear students. Okay, which is equal to like this. So this is x, means this can be also written as q of minus 1.25. 1.25, my dear students. Okay, very very important thing. Just I would like to bring it to your notice, my dear students. Okay, the very very important parameters. Just I would like to bring it to you over here. Okay, similarly, we are going to do one more problem, my dear students. The very very important one. The very very important one, my dear students. Okay, listen. One more problem, my dear friends. Okay, here he has given a function, my dear friends, in such a way, a Gaussian, okay, that is random variable. He has given the, my dear friends, the value similar to the previous problem, but the changes he has made is just, okay, x is a Gaussian random variable. Next problem, x is a random variable which is Gaussian, my dear friends, which is a Gaussian, my dear friends. He has given that the mean value equal to 1. So what is the value of the mean, my dear friends? He has given the mean value equal to, my dear friends, sorry, mean equal to 2, and the sigma square variance equal to 4, like that he has given. He is asking find the probability, find the probability x is less than or equal to 1. He has given, my dear friends, in this particular fashion. He has given in this particular fashion, my dear friends. Okay, so when the question will be given in this particular fashion, again, see, this is nothing but what? CDF, the representation. CDF representation, my dear students. Okay, when you are representing a CDF representation, he has given the 4 options, my dear students. Option A, he only given B, C, and D, my dear students. Okay, option A is Q of 0.6. Option B is Q of 0.5. Option C is Q of minus 0.5, my dear friends. D is Q of, my dear friends, 0.7. Okay, first write the representation f of x. F of x equal to 1 minus q, my dear friends, which is equal to 1 minus q, which is equal to what I am writing. Okay, x minus m by rho. Here he has given a rho square, rho equal to 2 only. Then f of x equal to 1 minus q, my dear friends. This is x equal to 1. How much? It is nothing but one value. 1 minus 2 by rho. Rho equal to how much, my dear friends? 2. So you are getting this value is 1 minus q of minus 0.5. This is capital F of x. Okay, but I told you, my dear friends, q of x plus q of minus x equal to 1. Here x value is this one. What is x? X equal to 0.5. So this particular value is equal to q of x, which is equal to q of, my dear friends, 0.5. So option is B. Is it right, my dear friends? Option is B, my dear friends. Okay, very very important thing. Just you have to remember over here. Is that clear? Is that clear, my dear students, over here? Everyone? Everyone? Similarly, we are representing the 2 more functions, my dear students. After that functions, I am closing the today's class. One is the binomial distribution function, my dear students. Okay. Next question. Binomial distribution function. binomial distribution function, my dear students. So what is binomial distribution function? Here also I am going to tell you. Okay, binomial distribution function, my dear students, for what purpose we are going to use means this function is used, my dear students, in the transmission of the digital information in the message of n bits. Okay, so this particular function is used, my dear students, in the transmission of the digital information in a message of n bits. Okay, here also we are representing, my dear students, two functions. Okay, one is the function which is equal to PDF. Okay, m equal to 0 to n, which is equal to NCM into P power m into Q power n minus m and del of n minus m. This is the formula, my dear students. This is probability density function, PDF, my dear students. Is that clear up to here, everyone? Similarly, we are representing the cumulative distribution function. Cumulative distribution function, which is equal to, this is how it will be, my dear students. Okay, m equal to 0 to n, my dear students, NCM P power m into Q power n minus m and u of the function u of n minus 1. But this unity function, this is, they can be written as like this also. Okay, so here this can be written as, this is nothing but 1. So we can represent the above function. We can write down like this particular fashion also. See here, what is this n? N is the digital transmission of n bits, and m is nothing but the what, my dear students? The number of errors in the message. M is nothing but the number of errors my dear students. Okay, what is n? N is the number of bits, and my dear students, what is p? Is the probability of correct reception of the bit. I told you in MAP and ML decoding, probability of the correct reception of the bit is p, my dear students. Once again, n is what, my dear students? Number of bits, and p is the probability of correct reception of the bit. And my dear students, here what is m represents number of errors in the message, my dear students. Okay, now here what happens means in binomial distribution as number n increases, okay, number perugutuna koddi, my dear students, the binomial distribution is difficult to handle. So మనం ఈ డిస్ట్రిబ్యూషన్ వాడలేం నాన్న, n వాల్యూ పెరుగుతున్న కొద్దీ. ఓకే, అందుకే మనం ఏం చేస్తాం, వీఆర్ గోయింగ్ ఫర్ ద నెక్స్ట్ డిస్ట్రిబ్యూషన్, అండ్ దాట్ పర్టికులర్ డిస్ట్రిబ్యూషన్ ఇస్ కాల్డ్ పాయిజన్ డిస్ట్రిబ్యూషన్. ఆ డిస్ట్రిబ్యూషన్ ఏమంటాం నాన్న, పాయిజన్ డిస్ట్రిబ్యూషన్ అంటాం. ఓకే, ఆ పాయిజన్ డిస్ట్రిబ్యూషన్ ఎలా ఉంటుంది, మై డియర్ స్టూడెంట్స్? పాయిజన్ డిస్ట్రిబ్యూషన్, now see why I'm going for the Poisson distribution, because as the n bits are increasing, the binomial distribution is a failure one. Okay, then I'm going for the Poisson distribution. Here also we need to represent the PDFs and CDFs. PDF small x, probability density function, okay, which is equal to m equal to 0 to n, my dear students. Very important, e power lambda, my dear students, into lambda power m, my dear students, by m factorial, by m factorial. my dear students, this particular one. Okay, this is the function, my dear students. Okay, similarly, if I am simply changing this one by u factor, then it becomes a CDF. Okay, then what happens? Capital, which is equal to P of this particular one, x is less than or equal to x. అంతేగా ఇది మీకు ఆల్రెడీ చెప్పాను చూడండి, ప్రీవియస్ క్లాస్ గురించి చూడండి, which is nothing but m equal to, my dear students, 0 to n and e power minus lambda, my dear students, into okay lambda power m by m factorial, by m factorial, my dear students. Okay, and here also you are going to get u of n minus m, but we can replace it and you can write down with the CDF also by taking out, my dear students. Okay, this particular one also. Okay, we can take it and we can represent ఇది కూడా తీసేయచ్చు వన్ అనుకోవచ్చు జనరల్గా. We are representing in that particular fashion, my dear students. Okay, we are representing. Now here also we need to go for the what are the formulas that will comes under the two distributions, mean square and all these particular values. Two distributions. One is binomial distribution. Second one is Poisson distribution. Okay, here the mean formula, okay, which is equal to n into p for binomial distribution, and a sigma square which is equal to formula np into 1 minus p. I told you n is the number of bits and p is the probability of the correct reception, and standard deviation you know under square root of np into 1 minus p, my dear students. Okay, similarly Poisson distribution, here also same, mean equal to n into p, but in Poisson distribution which is equal to lambda, which is equal to lambda, my dear students. Very very important. Here also lambda square which is equal to, sorry, this is variance equal to n into p, and standard deviation equal to, my dear students, which is equal to n into p, my dear students. Like that we are representing in different parameters over here, my dear students. Okay, the very very important one. Okay, all these are the various parameters. Just I would like to bring it to your notice, my dear students. Okay, okay, similarly, my dear students, now problems based upon the Poisson distribution. My dear students, listen carefully. Poisson distribution. Let the 3% of the items made by the factory are defective. Okay, the 3% of the items made by the factory are defective. Question is, items, 3% of the items are defective. My dear students, okay, defective always we are representing with the P. Okay, which is represented by P, my dear students. P equal to 3% means 0.03. Okay, and find the probability, my dear students. He is asking a sample of how many complete total items are. Total items n equal to 100, my dear students. He only given. Okay, now he is asking, my dear students, there are 4 defective items in a sample of 100 items. Here the probability of x equal to 4. దీంట్లో 3% అంటే ఈ 100 items లో 3% ఉన్నాయి, but in that 4 are defective. 4 defective items. Defective items, my dear students, He wants to solve these questions using Poisson distribution. Poisson distribution, my dear students. Okay. So what is the formula for the Poisson distribution? Lambda power m, my dear students, into e power lambda by m factorial. m fact m factorial, my dear students. Lambda power m. Okay. So first we need to find out this. Okay. This is x equal to m. Ardham didi. So m equal to 4. My dear students. Okay. And m equal to what, my dear students? Defective items. Okay. And lambda equal to what is the formula? Lambda Japan. Lambda n into p and coach. N items 100. P ichchadu. Lambda equal to, my dear students, 100 into 0.3. Sorry, 0.3. 3 you are getting. Okay. Then it will be 3 power 4, my dear students, into e power lambda minus 3 divided by m value 4 factorial. Then you are getting this particular value, exponential value is equal to 27 by 8 into 1 by e cube. This is the answer, my dear students. Okay, like that we need to solve. Okay, this question is also asked in the previous paper, my dear students. Okay, there is one more question that is asked. Based on the Poisson distribution, very important. A random variable has a Poisson distribution. X is a random variable, has a Poisson distribution. My dear students, P of x equal to 3, which is equal to P of x equal to 4. My dear students, find x equal to 6. Find x equal to 6, my dear students. Okay, so here means this is m values he has given, my dear students. He has given this one. Okay, as you know the function e power minus lambda power 1, that is lambda m is 3 by 3 factorial, which is equal to 6, which is equal to e power minus lambda power 4 by 4 factorial, my dear students, which is equal to 24. Then what is the value of lambda you are getting? Lambda equal to 4 you are getting, my dear students. Okay, then find out P x equal to 6. X equal to 6, my dear students. Okay, if I found out x equal to m, my dear students, because already lambda is there. Okay, so here e power minus 4 lambda into lambda power m by m factorial. Then it is equal to e power minus 4 into 4 power 6 divided by m factorial. M factorial here 6 factorial, my dear students. Then you are getting this value is 0.104. With that we are completed about all these particular distributions, my dear students. Okay, in the next class I am going for the very important one, and that particular one is the random process. Okay, random variables has been finished, my dear students, over here in a detailed manner. Similarly, the number of followers in the Facebook are day by day increasing, my dear students, as far as Unacademy is concerned, my dear students. The very important one. Okay, and Unacademy is in the number of followers in the Facebook, Instagram, and Telegram are day by day increasing as far as Unacademy is concerned, my dear students. Similarly, Unacademy Telugu channel, you are going to access the subject in 2 languages, Unacademy Telugu, English, There are number one India's Unacademy Telugu. Various different channels are there where you are going to access the subjects for different competitive level examinations in different languages. Thank you very much.